antiderivative of 2 over x dx. This is the kind of example that when we were originally learning our antiderivative rules, we said we couldn't handle. This was the one thing that the power rule couldn't deal with, was x to the negative 1. And now that we know our natural log rule for integrating, we can do this. So we can think of this as 2 times the antiderivative of 1 over x dx, and we know that that becomes 2 times the natural log of the absolute value of x plus c. It's important that we have the absolute value there. X in the original integrand can be any value, negative, 0, or positive. When we take the natural log of those values, though, we need to make sure that we're taking natural log only of positive values. We can see from this function that x can't be 0, that wouldn't be in its domain, so we really don't have to worry about that piece of it. But we do need to make sure that we're not feeding the natural log negative values, because that doesn't work out very well. So here we have 2 times the natural log of the absolute value of x. Now you do have some choices here. All right, we could also write this as the natural log of the absolute value of x squared plus c. And since the absolute value of x squared is going to be positive regardless of whether we have the absolute values or not, we could write this as the absolute value of x squared plus c. Here we don't need the absolute values because we're using 2 as a power, but in the original answer we needed the absolute values because 2 is a constant multiple, and we needed to make sure that the natural log was never acting on a negative value. But if we square those values first, natural log can't ever act on a negative value. Either answer is fine. I'm not really worried about which form you give it to me in, but you should be aware that because of those rules we have for logarithms, we sometimes have choices in terms of how we communicate our results.